Welcome to Revolutions, where we take an inside look at the gear industry. I'm Senior Editor Matthew Jaster from Gear Technology Magazine. I'm here with Matthias Pfadt from Klüber.
Exactly.
Thank you for joining
Matt.
us today. Let's talk about how Klüber is preventing wear and micro-pitting damage for gears and rolling bearings.
Yeah, to prevent this, I will focus on the industrial gear oils we have, because we have many gear lubricants here, especially with the Summit brand as well. So I will focus just on the industrial ones. And if we talk about prevention of wear and micro-pitting, we have to distinguish that wear is a failure that happens more in the regime of boundary and mixed friction, whereas micro-pitting happens more in the regime of mixed friction and fluid friction. So in the regime for wear, which is boundary friction, the additives have to do the job. And here we put inside anti-wear additives. And now it sounds easy because we just put in additives and they do the job. Now we have many surface active additives such as anti-wear, we have extreme pressure additives, we have corrosion inhibitors, and it's very important to balance all these additives, that the right additives work when they are needed. So we balance the additivation to prevent wear. If we talk about micro-pitting, there the base oil plays an important role as well, because micro-pitting is a fatigue damage. So it happens after millions of operating cycles, and is known, for example, from wind turbine gearboxes. So there we tune the composition out of base oil and additives, because the stress level induced from the base oil friction properties is very important. One example for you, if we look at food grade lubricants, there we are limited which additives we can use. If we use PAO and we add food grade additives, we cannot achieve high micro-pitting protection. If we do that with a polyglycol, it is possible because friction properties of the base oil are better.
Okay. Describe the testing that Klüber does to determine the performance characteristics of its products.
So for a gear lubricant, we do all the standard testing that is required in order to prove the functionality in a gearbox. That might be paint compatibility, that might be foam protection. We check corrosion protection with copper and with steel, and elastomer compatibility and so on. So that's what we do. What else we do is we have special test strips that have gained more importance in the last years. I would like to highlight two. One of them is the EHL tribometer. So it's a ball on disc tribometer. And with this ball on disc tribometer, we can measure either friction or film thickness. So we are able to do the fine-tuning of our additives with the friction measurements, because we can see how the tribofilm is built. And with the film thickness, we can directly tell our customers how the lambda value is, which is the ratio out of film thickness and surface roughness. The second test trick that is very important is dynamic elastomer compatibility testing. This second test trick tests the actual radial shaft seal in combination with the lubricant. And there we can now test the real operating conditions of the customer. It might be a robotic cycle, which is very fast and oscillating. It might be a continuous operation as of an industrial gearbox. And we directly can show that this combination is suitable and can reach the required lifetime.
What were the most significant and surprising results from these lubrication tests?
So the most significant result that we got was on FCG. Mm-hmm. And on the FCG test rig, we did a micro-pitting test with an industrial gear oil, isoviscosity 320. And this industrial gear oil showed at the standard test conditions, which are 8.3 meters per second peripheral speed and 90 degrees C sump temperature, it showed a high micro-pitting protection. And then, as this gear oil viscosity is used for wind turbines that operate at cooler sump temperatures, we reduced the test temperature. And we reduced it to 60 degrees C, and we reduced it to 40 degrees C. And with this lubricant, we saw that micro-pitting protection went down with a decrease of temperature. So at 60 degrees C, we just had a failure load stage of 9, which is medium micro-pitting protection. At 40, we could just reach 8, which is even less micro-pitting protection. So this was very interesting for us to see that even if the viscosity of the fluid is increased, because the temperature is reduced, if the additives can't work at this temperature, you do not have the protection you want to have.
Okay. How has Klüber applied these test results to its product line?
Yes, that what I mentioned before with the different temperature levels. So we always check our additivations that they work not just at one temperature, that they work over a wide temperature range.
Okay.
So that's what we do and what we test. Then we banned metal containing anti-wear additives because we found out that at higher operating temperatures, they have a tendency to form residues. And these residues might clog filters, or they might get you into trouble with oil injection devices, or these residues might interact with the seals and disturb their functionality. So that's why we don't use this technology.
Okay. Which recommendations do you have for the gearbox design engineers?
Yes, so if you do gearbox design and if you do a calculation, for example, for micro-pitting protection, and you have a lubricant or the lubricant data in your KISSSoft, Romax or whatever, take the actual test results at the specific temperature that fits your application best. So if you have an application that will operate at 60 degrees C, don't take the test result from 90 degrees C, take the one from 60 degrees C. And this advice is not just valid for micro-pitting protection, it's valid for scuffing tests or for bearing tests as well.
Okay. And how do you think gear and bearing lubrication will improve in the future?
Yes, the lubricants, of course, have to follow the market trends that we have in order to fulfill future requirements. And we can see that one market trend is that power density of the units is increasing. And what else we see is that oil change intervals and seal change intervals are getting longer and longer. That's one market trend we see. Another market trend is that customers are getting more sensitive to leakage topics. So that's one we have to address. And a third market trend is that legal requirements are changing. So there's a trend to more sustainable raw materials that we are using, for example, in the marine industry, which is biodegradable raw materials, and stronger requirements for food products, or as well, we are limited with the resources we can use, for example, with REACH requirements in Europe. And these trends lead to more synthetic products, and they lead as well to more specialized products. So less multi-purpose, more specialized products. And I just gave a speech here about extreme trends, which is, for example, e-mobility, where you really have to reduce friction. Cooling is a very important topic there. There, the new water-based lubricants like Hydrolubes are even interesting and might help to solve the future problems.
Okay. Well, thank you for your time today.
Yeah, thank you, Matt.
Learn more at www.geartechnology.com. Thank you.